Hey Finxters, and welcome to today's Coffee Break Python. In today's video you're going to learn about the Python Hex function. So the Python, it's one of Python's built-in functions. So there are 81, I guess there are 81 built-in functions. So Python's creators thought these are the most important functions that every Python coder must know. And in today's video you're going to learn about the Hex function. And honestly, I think among those 81 very important functions, I think the Hex function is one that is like at the bottom of the list regarding importance. But still, I think it's a good exercise to because I mean, as a coder, as a programmer, you need to know about binary representation and hexadecimal representation of numbers, because in the end, everything is a stream of ones and zeros. Everything will be converted to binary numbers and oftentimes to hexadecimal numbers as well. So you need to understand the concept, and therefore I think it's valuable to learn about the built-in hex function. So the function per default, it takes one argument, an integer argument, and returns a hexadecimal number with a prefix 0x. So you can let's open the code shell to have an example. So say we pass the integer number 1, decimal number 1, we get the hexadecimal number 0x1. So each time you have this prefix 0x, it should indicate to you that it is an hexadecimal number. And for example, if you like use the oct function, it has the prefix 0o for octal number. Okay, so it's an octal number. And if you, for example, convert the decimal number 1 to a binary number, you get the prefix 0b. Okay, so you see the first two characters of those numerical representation of numbers in different numerical systems are always used to indicate the type of the number. So what is the numerical system, numeric system of this converted number? Okay, so you have already seen hex 1 is 1 as well. Yeah, so hexadecimal just means that you have, like, you don't have. Let's open a drawing board. So in the decimal number system, like, you have a combination of 7, 8, 9, and basically 0. So you have 10 numbers, 10 different, like 10 letters, and all numbers in the world, like all integer numbers, are just a combination of those 10 different numbers from 0 to 9. And in the hexadecimal number, you just have a few additional numbers for each position. Yeah, and the additional numbers are A, B, C, D, E, and F. So you have up to 16 different numbers, yeah. So you have 6 more than the. So basically, these are, so the hexadecimal number also has all numbers from decimal systems, and it also has additional numbers, and they just use the alphabetical letters as numbers in this representation. Okay, so for example, if you have a number 100 in the decimal system, it would be converted to let's use our function to convert this. Hex 100 would be converted to 64, yeah, in our hexadecimal number, yeah. So which means that basically this one here, we have what it means is we have 0 times 10 to the power of 0, and we have 0 times 10 to the power of 1. So this is like the definition of a numerical system, and we have 1 times 10 to the power of 2. And you see, so each position I resides in the base 10 to the power of I. So everything has the base 10. Each number has the base 10, and if you sum those up, you get the numerical value. So 1 times 10 to the power of 2. This is basically the value of this number in the decimal system. And to obtain this same value, you can do the following here. So we have 4 times 16 to the power of 0, and we have 6 times 16 to the power of 1. Okay, so 16 to the power of 0 is 1. Yeah, so we have 4 times 1, this is basically 4. And then we have 6 times 16 to the power of 1 is 6 times 16. So we have 60 plus 36 is 96. And if you sum those up, basically, you also obtain the numeric, like the decimal number 100. Okay, so both basically are the same numbers. They just have a different representation in the numerical system, a different numerical system. Okay, so and this is what the hexadecimal function basically does. It indicates you the system 0x for hexadecimal, and then it gives you the number 64, which is the hexadecimal number for the decimal number 100. And so for example, you can also do like have very large numbers, say 99999 or so. It's very efficient way, and you can also try negative numbers, and then we give you this negative representation. Okay, so this is how you can use the hex function to convert decimal number to convert any number basically, or any object, to a hexadecimal representation. But what if you have a custom object now? In some cases this is needed. For example, if you have a class, say let's make it a class customer, and the customer has say value, like lifetime value or so, and then you set self.value is value, so you initialize the attribute of this customer. And now let's try to print hex. First we need to create a customer, so say we create Alice. Alice is a customer with value, say $1,000 or so, and then we have we print the result of hex, and we pass Alice, so we now pass a custom object into it. So would this work? Basically no, it throws an error because a type error. It tells us that the customer object cannot be interpreted as an integer. Okay, so why is that? Why can't it interpret it as an integer? Yeah, I mean the customer object is just that, it's custom object. What is the integer value you want to convert in a hexadecimal number? Python doesn't know it. But you can basically define it using the index method. And the index method just returns any numerical value. So you can return a constant numerical value for all objects, or you can, like 42, or you can simply return another integer based on the data, based on the attributes of this particular customer. So for example, we could return self.value as the result of the index function. And now basically this custom object has an associated integer value that can be converted to a hexadecimal number. So let's run this same code again, and now you see it's not an error anymore. Okay, and so we get the result 0x3e8. So e is just the numerical value for 15, for the base 15. Okay, I think 15. Is it 15? Yeah. No, 14. It's 14 actually. So we have 10 is A, 11 is B, 12 is C, 13 is D, and 14 is E. Okay, so we have 14 actually. Good. So if you convert, say 1,000, you actually get exactly this same number. Okay, so in this way you can basically pass any object into the hex function and define your own custom hexadecimal number. So this is really powerful. Then one little question I got asked sometimes is how to convert a float value to so on a blog post I get asked sometimes on a blog post on the same topic, how to convert a float value to a hexadecimal number. Okay, so because it doesn't work like this, so you cannot simply pass, say, a float value into the hex function. It just gives us the same type error. The float object doesn't have the index function defined, index method defined, so it cannot be converted as or interpreted as an integer. So what to do? Yeah, you can simply call, like on the float object, you can call hex. That's it. Okay, so this way you get the representation of the hexadecimal number. It doesn't look pretty, but it's the same. I mean, we have the 0x prefix, we have a float value, boom, boom, boom. Actually, it goes all the way here. The character A is basically numerical value as you have seen here. Yeah, so character A is just this value here. Yeah, so it's a numerical value of 10 in the hexadecimal numeric system. Okay, so the number goes all the way up to here. Then we have the suffix p, and then we have the exponent. So this is basically a numerical representation of the decimal number 3.13. Okay, so that's it. That's how you can convert an hexadecimal float to a hexadecimal number. You can use the hex function as built-in. You don't have to import anything, and it's it's a very effective small little function. Okay, thanks for listening to this video, and see you in the next video. Bye.